Hi everyone once again, and we have Andrii Soldatenko here. He's a CTO of Ethos in Ukraine. Andrii likes testing and programming. Also, he's working as senior Python backend developer via TopTal under Social Network. He boasts expertise as a Python and Golang developer with strong hard and soft skills. He has deep knowledge of automated testing and really understands how to assess and improve project quality. Andrii likes to solve difficult tasks, algorithms, and takes part in sport programming contests. He is also interested in databases and Unix-based operating systems and has fallen in love with natural language processing and text mining. Please welcome Andrii with his talk on debugging concurrency programs in Go. Welcome.
Hey, cool. Can you see my slides? Nice. Hello. Thank you for coming my talk today. I'm Gopher from Ukraine. I'm father of two children, and today I'm going to invite you to the journey about different debugging concurrency techniques in Golang, so we can discuss it in more details. Cool. Concurrency programs, like the interest of concurrency programs still growing in recent years. So, but debugging still challenging because debugging sequential programs still hard, but debugging concurrent programs is more hard as you can imagine. What is debugging sequential programs? Like the classical approach, as you can see on this slide, I'm trying to debug simple unit tests using default Delph debugger. It's very simple approach which involves rapidly stopping the program on different lines, like research and inspect different values of variables, etc. And then you can continue or reset this loop back. So this style of debugging we call it as like cyclical debugging because we do it in loop. Each time we jump between lines until we find a bug, so we can fix it, and after that we can repeat it as much as we want. So unfortunately, parallel programs don't always have reproducible behavior. For instance, even when they run in the same input, their results can be radically different, and this difference caused by races, which can occur like when we run two different parallel like execution flows. From another side, there are tons of books and resources about development, especially concurrency development. There's a great book by Catherine about concurrency in Go, and different and other books about concurrency in general, and Golang documentation. But there is still not enough information how to debug these programs, especially concurrent programs. So it's still tricky and complicated. So before we start, what is goroutine? So just to visualize goroutine, and before we start working on it, goroutine is just something I can illustrate as a struct, which from source code. So there are lots of attributes, so we can imagine how big goroutine and how complicated the logic. I highly recommend to read, if you did not have a time to do it, the article Goroutine Size, which really great about some research and development. What's the size of goroutine, how and how it works under the hood. So yeah, feel free to use this link. But have you ever imagined why we, or do you know why we call it goroutines? What is strange word? So goroutine, because they call goroutines because there are another names like threads, coroutines, processes, and so on, is not accurate names. And under the hood, goroutine is a simple model. It's a function which executing concurrently when other goroutines in the same address space. So it's lightweight, as we know, and it costs little more than allocation, etc. So know this information, we can dig into more practical stuff. And in one of my talk, a person from audience asked me, but okay, we can debug any program, but how we can debug concurrent program? So, and like the first idea that you can suggest, it's using Playground. So you can create some small program like I did, and as you can see, you can run it in Go Playground. Is just place where we can run different programs. And as you can see, the output is same as each time when you run your program. So it's because of, by default, Go Max Pro's set to 1. So if you run it locally on your machine and you have more cores than 1, or you change it, so you can see different results. But in this example, you see each time same. So it's trick how you can change the flow. Like so, when you set up this environment variable, we do. It means that scheduler of Golang just get one by one goroutine. So like technically, we run like sequential execution flow. So. Next idea we can suggest is just probably it would be great to visualize goroutines. So, for instance, I have this example, and I suggested very not well-known library from GitHub, which just do very simple stuff. We print we configure logger, and when we print, we change colors. So in your console or in your terminal, you can see different colors. So, and if we run loop and run lots of goroutines, so we can do this funny picture like in my next slide. So we can see one goroutine colored in first line. It's from main routine, and another goroutines from the loop. So we can draw different colors. In production, it's absolutely useless. So, but it's fun. You can just play, and sometimes when you debug in late night and it's really complicated to find issues, sometimes I try to visualize what I'm doing, or in paper or in code, and it's really useful to understand like the flow and why it works like it works. So yeah, it can be useful, but not too much. Okay, so but if you need to visualize goroutines in more advanced way, I suggest article by one of our Ukrainian Gopher. It's Ivan Daniluk, who created great article. So unfortunately, GIF doesn't work well for me in these slides, but you can just go to this article and see different nice pictures, how Ivan change goroutines and draw these beautiful GIFs, so you can understand like how it works. And dig into on this article. Okay. Next idea, which we can suggest in mind, it's also not about debugging, it's more about tracing. It's absolutely different concept, but it can be also useful. So we know that we run goroutines, but then scheduler from Golang maps these goroutines to operation system threads. So, and it's not usually like one-to-one. So you can have less cores, or you can have millions of goroutines, but it doesn't mean that we run millions of threads. So, and if we want to check how it works, so we can use this magic environment variable go_debug with value scheduler trace. And like in my example, it's 5,000, it's 5,000 milliseconds. So each 5,000 milliseconds, we will print trace logs. So if we run your program, we can change, we can trace what's going on inside scheduler, and it can help us to understand, for instance, if you have very big queue of tasks and you try to understand, like, are we using all the resources, or are we map it efficiently to our server and resources, we can use this environment variable and this kind of tracing. Yeah, and as I said, it's not optimal from, I mean, maybe not best word optimal, but we should keep in mind that like number of goroutines not equals to number of threads. So scheduler manage all this stuff, and sometimes it's unbalanced and it can cause some performance issues for us. So we need to trace it. Okay. So this part is more or less clear. It's just about tracing and different what you can do without even starting any debuggers. And now I would like to show you how you can use debuggers. For instance, Delph or GNU debugger, which very old school. And I don't want to guide you how to use Delph or GDB. I assume you already have some experience. If not, I highly recommend you just find information in internet, or just you can watch my previous talk from FOSDEM. So where I just demonstrated all nuances of how to debug using Delph or GDB. So you can extend your knowledge base and find different tips and tricks how to debug it. So as I mentioned, I assume you know something about it. So okay, like generally speaking, good question is we can start to investigate like how we can set breakpoint inside goroutine. So I have few demos for you. So I just need to switch and share my screen. It will take 1 sec. Okay. So I hope you can see it. I will wait until it's loading for everybody. So as I mentioned, we already have example of program, which very simple. So I will just demonstrate it for you. So it's just something like main function, and we create few channels, and the idea is that we start few goroutines like hello world, and that's it. And then we print message and read from channel and print results. So that's like concepts of Golang in this small slide. And the idea is like, okay, we have this program, and I would like, if you're familiar, as I mentioned, with Delph, so it's easy. You can just debug any function. But okay, right now we have goroutine, so we run go space say, so we run, and we not wait for it in this line. So what next? Yeah, and let me show you. Okay, if we try like directly, just stupid try, if we try to set breakpoint to say, yeah, B is just alias for break, and say is just name of a function. So I just use a lot of shortcuts. So you can set breakpoint using main.go and semicolon and line number, but you also can use function. So, and the idea, if I set breakpoints, so we can print all breakpoints. So as you can see, we have only one breakpoint at line 7 in main. Say so. Now, if we continue or run our program, we, like I assume, we should stop. So, and as you can see, we should stop intuitively. I think we should stop at least 2 times. So if I continue, yeah, as expected, we stop and say, then we can just click next, just next line. So it's print of s. So just to make sure that we stop when we run hello, which makes sense. And and when we, okay, it's first time. So next we click continue. Okay. Oh, so we stop only once and we ignore second time, but we print hello world, and as you can see, everything works, but is not expected as at least I expect. So, and as you can understand, we just we can debug only one goroutine and at time. So if we just ignore second one. But there's the idea which I found useful for me. We can fix it. So if we start again and we say breakpoint, I don't know, main.main. So we can print breakpoints. So it came as in previous example, but how we can, for instance, stop 2 times. So the answer can be conditional breakpoints. I already showed it a lot in my previous talks, but just long story shortly for you, conditional breakpoint is something which very familiar with any debugger. So it's when you have a huge loop or whatever, you can say, I would like to set breakpoint, but I would like to stop when some condition come. So we can, for instance, play with this. So if your loop is, I don't know, 1000 iteration, no need to, if you put breakpoint inside, it means you need to click next 1000 times, which absolutely doesn't make any sense. So return to our problem. So if we say conditional breakpoint, we can set using conditional, which makes sense. If you just forget something, you can just click help, and it's easy, or help and number of comments. So condition, breakpoint name, and Boolean expression. So we say conditional breakpoint, breakpoint name, okay, 1, whatever. So, and I would like to say stop when s equals world. As you remember, we stop in hello, but I would like second goroutine. And that's it. So, and if we click, yeah, and also we need to set breakpoint inside say, otherwise we will skip this function. So if we print all breakpoints, we can see that we have one breakpoint at main with condition, another breakpoint in say. So if we click continue, oh, yeah, it makes sense. I need to, we need to say, or we need to set breakpoint inside say. So it's, let me check the first code. Yeah, it would be great to set it, let's say, after line number 9 or number 8. Okay. And conditional breakpoint is equals 1. So, as you can see, we stop here. If we print s, we inside goroutine, and also we can print current goroutine, which we are running using keyword goroutine. So it can help us to understand where we are. Also, we can print all goroutines, so we can understand how many goroutines we run. So as you can see, the most important part is goroutine number 6 and goroutine number 7. So this asterisk means we are inside goroutine 6, which worked for us. So we can easily see what we do. Another goroutines is just, if I'm not mistaken, some system goroutines, and one goroutine is main goroutine. So simple program and so many goroutines. Okay, and next we can just click next. So, and we exit. So, small conclusion. As a result, yeah, we can't jump during our classical, as I mentioned, sequential debugging or debugging of cyclic debugging, but at least using conditional breakpoint, we can manage which specific goroutine to run, or yeah, and if you know your some values or inputs for your goroutines, or if it's in loop, so you can debug your specific goroutine you want. So it's really useful. Okay, cool. And before we return to slides, I have one more good example for you. It's second important question, how to debug channels. So even if it's possible to debug channel, or what you can do with channel. So I spoke with like all sorts of Delph, and we on FOSDEM, so we decided, yeah, we had conversation about it would be great to have few features. So I will show you what you can do right now and what still doesn't exist. So if you, yeah, I have another example with channel, which is very small. Like I just create channel, buffer channel of integers with size 4. Just write to channel some numbers and close channel. Not big deal. So okay, and let's say we try to debug it. So if we run Delph, channel, so we inside main, so we can click next. Okay, and now, like right now, you can like inspect channel, so you can see what is channel, like count size and some element type and how it looks like. So it's very useful. Also, you can see, if you know how channel works, you know what's channel buffer, etc. So you can print channel buffer. It's right now just zeros, like initial values of slice. And when you add element to channel, you can check your buffer changed. So that's cool. I mean, you can monitor your channel, etc., etc. So even if you continue each iteration, you see your channel is extended and elements updated, etc., etc. So it's super simple, not big deal. But it would be great, or somebody can assume that there is a very useful feature of debuggers, especially of Delph, you can say like like you can do set. So set is like you can set value to variable. So it's great. You can change, for instance, if you debug and you decided you need to change value, you can change it, and then when you run function, so you understand that flow can be changed, so it can be useful. But it would be great if we can do like set our channel another value. So yeah, it still doesn't exist, but it's nice to have. So maybe in future somebody can implement it, or even I can do it myself. Cool. So returning to my slides. Where is my slides? Okay. So returning to my slides, we can continue. Yeah, it was 2 demos. So, and second one was how to debug channel. So right now you know how to debug channel. There are like lots of advantages. You can learn better how it works, like goroutines, channels, all this concurrency, and you can better understand how your program works. So you can, yeah, I mean, there are lots of pluses. Okay, so it's time for old school GDB. So GDB is like GNU debugger, which I'm pretty sure you maybe used or heard at least once. So to run it with Go, you need to do lots of nuances. I mentioned in my previous talk that you can first you need to build your binaries with specific flags. Especially, you must enable compressed dwarf false, which means dwarf is a format, like data format between debuggers and your process, something like it. So Delph can understand compression, like compressed dwarf, which default value for Golang binaries, but GDB does not, so you need to disable it. Yeah, and with GDB, also you can print some goroutines which you're running. So you can see which goroutine is running, which is waiting. If you change function, you can see the updates. So more or less same as you can do with on Delph, but Delph is, in my opinion, more user-friendly. Also, maybe useful part, you can print backtrace of current running goroutine. So if you connect it to goroutine, you can see what it's doing. Also, same as with Delph, you can jump between goroutines. I didn't cover it, but you can do it after talk, so it's easy. I just show how, so you can spend one evening maybe to play around. Also, you can print backtrace of goroutine by goroutine ID. So as you can see in my example, it's a little bit cutted maybe, but the idea is simple. You run goroutine ID of goroutine and backtrace, so you can print what's inside this goroutine. As you can see, just main. So like main goroutine, as you know. So this part of debuggers. So we don't have lots of time, so I just jump to next one. Deadlocks happen and are painful to debug, and this is a huge part of any concurrency programming. So just to be short, deadlocks in when for instance, one thread or process reading to something, another waiting, and it blocks each other. So there is no, I mean, there is no way to exit from this state. And in next slide, like how we can detect such deadlocks, the program will get stuck on the channel, like on the channel send operation waiting forever for someone to read the value. And Go is able to detect such kind of situations like at runtime. And here's the output of the program. So it's a very dummy example, but as you can see, if you run this program, you can see like all goroutines are asleep and it's deadlock. But Go only can detect if all goroutines asleep. But if like your main program is working or another goroutines is working, but part of or subset of goroutines deadlocked, so Golang will not preserve you on it. So you need to take care of it by yourself. So that's why for real world example or complicated scenarios and tools, I found very interesting library Go deadlock. And for instance, this library, there are lots of information in documentation. You can review it, but for instance, using this library, I mean, CockroachDB use this library to prevent complicated deadlocks. So the idea is you replace standard mutex lock for this Go deadlock library, and it can help you to find such cases in your real world production. So highly recommend to review it, especially if you're working on heavily concurrency production code, so like databases or whatever. It's close to final, but as a bonus, I created by myself like 7 simple rules for debugging concurrency applications, which I use before I start to debug anything. So never assume a particular order of execution. So in general, try to not assume a lot, especially in programming. Another rule, implement concurrency at the highest level possible. So if your library do some business logic, etc., try to not use inside any concurrency. So try to decouple it, and you can delegate it to another to client code. So client code can take care of it. As I mentioned, don't forget, Go only detects when the program as a whole freeze, not even subset or goroutines get stuck. But even if your process gets stuck, so you can use something like strace at least to find why it's sleeping or what, or like, do we know what we are waiting for? So and all this like trace like tools. And last but not least, conditional breakpoints is really your best friend, even for concurrency application, especially when you can assume execution flow, so it can change. So you can, by the way, this idea is general for any concurrency and debugging. So like if you have 3 node server, try to reduce replica set to 1 and debug it. And it helps you to make it reproducible. So if you're not sure what's going on, use schedule trace for learning or studying or for production tracing. And as a bonus, yeah, Go deadlock is really great. So I know at least few libraries, huge libraries using it. So it's very promising, at least for me. So there are lots of information which I can't even show you because we don't have so many time. But I created a few slides of references. I will share these slides in Twitter after this talk or in chat. So you can just, it's a little bit randomly, but there are best articles and references which I found interesting, and so you can review it and read it. If you still need something interesting, you can follow me in Telegram. I'm author of GoldenLock for 2. It's a Telegram channel about some of my thoughts about GoldenLock. Thank you, and I will wait for your questions, and I will jump to just to repeat this link. And until we're waiting, we can discuss it. Oh, Daria is coming. So
yeah, I'm back. Thank you so much for your great talk. And I already liked the last one of the last slides, and especially the thought about never assume a lot in coding and in life. That's my life motto.
Yeah.
Thank you. Let's see. We have only minutes for Q&A, but we'll be fast. There are 2 questions in the Q&A chat. And the first one is, could you configure these tools into an IDE like GoLand, for example?
Yes, you can. So GoLand by default use Delph. So Delph is a several client debugger. It has 2 parts, and you can run and it runs your program. And GoLand is a client part. But when I run it during the slides, I use client and server at the same time. So if you go to my previous talk, I already demonstrated how you can even debug from Docker or from Kubernetes. So yeah, you can. I mean, it's very easy. In the second, okay.
Oh yeah, and the second one is how often it is needed to debug channels. Can you share any previous experience debugging any issue with channels?
I mean, it's not highly recommended, but if your channel, the type of channel is strange, or you're not sure that you pass correct data or something with your buffers, I mean, it was, at least for me, useful.
Yeah, and the last one is a request to go back to the previous screen with the slides.
Yeah, but so, we can share slides after talk, I think. Not
yeah.
big.
Yeah, I think you will do it on Twitter, and the organizers will also share it on the conference Twitter as well.
Cool.
So yeah, if you folks have any more questions, then go ahead and go to speakers page and ask them to Andrii directly. Also, we'll have a big break now after this talk, and you can go and check out the sponsor booths and join the random networking as well, which will be on. So once again, Andrii, thank you very much for the session, for the talk, and it was great to have you, and we'll see you around in the platform and in the speakers chat.
Thank you.
Thank you.
Bye-bye.
Bye.